In Chapter 5, we're going to look at different techniques of integration. So far, the only technique besides our basic integration has been use substitution. In 5.1, we're going to learn how to integrate by using integration by parts. Integration by parts is used when we have the product of two functions and we're asked to integrate them where use substitution doesn't work. What integration by parts does is it trades in one integral for hopefully a second integral that is easier. And that'll make more sense when we go through the examples today. Let's try to look at how they developed the rule for integration by parts. It really comes from the product rule. So say we have the derivative of u of x times v of x. Well, the product rule would result in that. Now, if we arrange this by isolating uv prime, we end up getting uv prime is equal to d by dx of ux vx minus u prime times vx. Now I'm going to integrate each term on both sides, and I'm going to get the integral of u v prime dx is equal to, well, the integral of a derivative, those cancel out, is just ux times vx, minus the integral of u of vx times u prime x. Let me just change the order here in this step going here. Now, v prime is really dv, and u prime is really du, and substituting those in, we end up with the formula for integration by parts. Again, you're not going to have to know how to derive this. I just wanted to show you where it came from, but this is the formula here that we're going to apply. Okay, in our first example, we are asked to find the integral of x times sine x dx. Now, what we have to do is, if we look at our basic equation, eventually we're going to be using the formula u dv is equal to uv minus the integral of v du, and that's my rule right here. So we have to look at, this is my original question, which matches up to this part. I have to let one function be u and the other one be dv. Now, how do we decide what to use? Okay, well, there is a strategy, and the strategy is called LIPIT. It's just an acronym. Our first choice is the natural log, so L stands for natural log if there is one. Next one is an inverse trig function, that's what I is. P is a polynomial, E is exponential, and T is a trig function. So looking here, again, we're looking for substitutions of u. There are no logarithms or inverse trig functions. The first thing I have as a polynomial is x. So I'm going to let u equal the x term, and dv is going to be the sine x dx. Now, looking at this formula, I need to come up with a du, and I need to come up with a v. So I'm going to take the derivative of u in terms of x, it would be 1 dx, and I'm going to integrate this guy, and the integral of sine x dx would be equal to negative cos x. So now I have my four things that I can substitute into these four different parts of the formula. So I have the integral of x sine x dx, which is my original question, is equal to u times v, so it's going to be x times negative cos x, minus the integral of v, which is negative cos x, and in place of du, I'm putting dx. So in this first term, when I multiply, I can bring the negative out front. This becomes a double negative, which is a positive. So now my final answer, I get negative x times cos x, and the integral of cos x is sine x plus a constant. And there would be your final answer. Okay, let's take a look at the next one. Very similar, the only difference is I have x times cos x, so again, I am going to let u equal x, and my dv will be my cos x dx. My derivative in terms of x would be 1 dx, and my integral of cos would be sine. So again, I have my formula. So it's the integral of u dv is equal to uv minus the integral of v du. So again, this is my original question. So the integral of x cos x dx equals u times v, which would be x times sine x minus the integral of v, which is sine x, du is dx. So this becomes x times sine x. The integral of sine is negative cos x plus a constant. So your final answer would be x sine x plus cos x plus a constant. Okay, example 3, we have a polynomial times a logarithm. And again, according to our Lippitt acronym, I want to let u equal the natural logarithm, which is going to be ln x. So I'm going to let u equal ln x. So therefore, the dv is going to be x cubed minus 6x squared plus 2 dx. So du is going to be 1 over x dx. And v, I have to integrate this, would be x to the 4 over 4 minus 2x cubed plus 2x. So now I'm going to substitute all of this into the formula. That again is the integral of u dv is uv minus integral of v du. So my original question, I'm not going to rewrite this out because it's a little long, but there's my original equation, is equal to u is ln x times v, which would be 1/4 x to the 4th minus 2x cubed plus 2x minus the integral of v, which is x to the 4th over 4 minus 2x cubed plus 2x times du, and du in this case is 1 over x dx. So this first part doesn't change. Now, before I integrate, I'm going to distribute the 1 over x into this, so I end up getting x cubed over 4 minus 2x squared plus 2 dx. And therefore my final answer is going to be ln x times 1/4 x to the 4th, minus 2x cubed plus 2x minus, now I'm going to integrate this ugly mess right here, and I'm going to get x to the 4 over 16 would be this integral. The integral of this would be minus 2/3 x cubed. So minus 2/3 x cubed. And the integral of 2 would be 2x. I have my constant. So now I can just distribute my negative sign from here to get ln x times 1/4 x to the 4th minus 2x cubed plus 2x minus x to the 4th over 16 plus 2x cubed over 3 minus 2x plus a constant. And that would be my final answer. Again, that one took a little bit more work, but that's how you set that one up. All right, sometimes you need to integrate more than once to get the desired answer. So in this case, again, I am going to let u equal my polynomial. So dv is going to be sine x dx. So du is 2x dx. And the integral of sine to get v would be negative cos x. So my formula is uv minus the integral of v du. So u times v is going to be x squared times negative cos x minus the integral of negative cos x, and du in this case is 2x dx. So this becomes negative x squared cos x plus, I'm just going to rearrange, I'm going to put the 2x out front, times cos x dx. And now I have to use integration by parts again to this part. So negative x squared cos x tags along, and now I'm going to let u in this case be 2x, and dv is cos x dx, so du is 2 dx, and v is sine x. So for this part that's highlighted in green, I'm using integration by parts again, so it's u times v, so it's going to be 2x times sine x minus the integral of v, which is sine x, times du, which is 2 dx. So now to work this through, this negative x squared cos x doesn't change, plus 2x sine x doesn't change. I'll bring the 2 out front. So this is going to be minus 2 the integral of sine x dx. So this ends up being negative x squared cos x plus 2x sine x minus 2. And the integral of sine x is negative cos x, so that's going to become a positive 2 cos x plus a constant, and that would be your final answer. Now, when you get examples like this, we can use a table method to integrate this. So here's how we would set that up. So we would take our u term, which would be x squared, and we would take our dv term, which was sine x in the original question. And for these, I'm going to take the derivative. I'm going to go down and say the derivative of x squared is 2x. The derivative of 2x is 2. The derivative of 2 is 0. And I'm going to integrate down this chart, or this column, and I have to go down 3 times because I took the derivative of the first term until I got down to 0, and now I integrate. Well, the integral of sine is negative cos. The integral of negative cos is negative sine. And the integral of negative sine is cos. Now, we draw in our arrows starting at the top term in the left column, and I'd go to the second term in the right column, and then this arrow, and I start with a plus sign minus plus. So basically I multiply the terms that are attached to this first arrow first, so it's going to be x squared times negative cos x, and then I put a minus 2x times negative sine x, and then plus 2 times cos x. And if we clean this up, 2 negatives is a positive, plus my constant, and notice that's the exact same answer I got right there. So the table method works. Again, you have to have the foundation here before the table method makes any sense. Okay, let's take a look at the next example. And in the next example, we're given ln x dx. So again, I'm going to let u equal ln x, and dv is equal to dx. So the integral of dx is x, and the derivative of ln is 1 over x dx. So therefore, using the formula again, I have u times v minus the integral of v du. So u times v is going to be ln x times x minus the integral of x, which is v, and du is 1 over x dx. Just going to change the order here. This ends up just becoming dx because the x and 1 over x cancel. So now if I integrate 1 dx, it's really equal to x plus a constant, and that would be my final answer. Now, sometimes one needs to do integration by parts 2 or more times until we get like terms with what we started with. And these are the most challenging ones you'll see right now. So let's take a look at sine ln x, and I forgot there should be a dx here. So this is going to be u, and this part is going to be the dv. So I'm going to let u equal sine of ln x du would be the cosine of ln x times 1 over x dx. dv is equal to dx, so v is equal to x. So therefore, we'll start this time. I'm going to start with the original question, and I'll show you in a second why. So I have sine of ln x dx is equal to u times v. So it's going to be x times sine of ln x minus the integral of v du, which is 1 over x cos ln x dx. So note that here these x's will cancel, and I have my original question, which is sine of ln x dx is equal to x sine ln x minus the integral of cos ln x dx. Again, I'm going to let this be u and this be dv. So u is cos ln x. du would be negative sine ln x times 1 over x. dv is dx, so v would simply be x. So the original question again is the integral of sine ln x dx is equal to x sine ln x minus, now again I'm applying integration by parts again, so u times v is going to be x cos ln x minus the integral of v du. So v is x, and du is negative sine ln x over x dx. So to clean this up, this first term, x sine ln x doesn't change. I can distribute the negative here to get negative x cos ln x. And if you notice, if I bring this negative out, this is going to become a positive. But when I distribute that, it's going to be the negative. And these x's cancel of sine ln x dx. Now notice, this is the same as the original question. So I'm going to add that to the other side of the equal sign. So I'm going to get 2 integrals of sine ln x is equal to x sine ln x minus x cos ln x. And then I have to divide everything by 2. So it's going to be x sine ln x over 2 minus x cos ln x over 2, and then don't forget your constant, and that's going to equal the integral of sine ln x. So again, we went through double integration by parts, ended up with something that was the same as the original question, added it to the other side, divided by the constant to get the final result. So again, a fairly tricky question, but one that can be handled nonetheless. The last part of integration by parts, we're going to look at definite integrals. And the question we're going to look at is the following. Say we're asked to integrate 0 to pi by 2 of 2x sine x dx. So again, we're going to use u substitution. I'm going to let u equal 2x. dv is going to be sine x dx. Therefore, du would be 2 dx. And v would be cos x. So using our u substitution, integration by parts, it'd be u times v, so it's going to be, this should be a negative cos x. It would be 2x times negative cos x will be negative 2x cos x, and I have to evaluate that from 0 to pi by 2, minus the integral from 0 to pi by 2 of v, which is negative cos x, du, which would be 2 dx. So cleaning this up a little bit, I get negative 2 cos x going from 0 to pi over 2. The double negatives become positive. The integral from 0 to pi by 2, and you could bring the 2 out front or leave it inside, it really doesn't matter. So now, before I substitute, I'm just going to integrate that last part. So the integral of 2 cos x would be 2 sine x going from 0 to pi by 2. Okay, so now, if we do, we could do them in parts, or we could do it all in one big thing, and maybe we'll just do that all in one big thing. So let's kind of ignore this part right here and just put this all to the limit 0 to pi by 2. So I'm going to get negative 2 pi over 2 cos pi over 2 plus 2 times the sine of pi over 2. So there's my upper limit, minus negative 2 times 0 cosine of 0 plus 2 times the sine of 0. Now your unit circle values will come into play here. We know that the cos of pi by 2 is 0, so this is going to drop off. The sine of pi by 2 is 1 times 2, so my upper limit is 2. And we know that times anything by 0, this is going to be 0, and the sine of 0 is 0. So my final answer to this definite integral is 2. So again, we can use integration by parts, to evaluate definite integrals as well. So that pretty much concludes the lesson. And your assignment is 1 to 6, the handout, which is right there. Again, those are the final answers on the bottom. If you have any questions, feel free to send me an email.